Okay, so I'm going to work through problem number 3 from the quiz. This was a stoichiometry problem. 6 moles of magnesium will react with 2 moles of diatomic nitrogen gas, to form 2 moles of Mg3N2, magnesium nitride. Now, one thing you might notice, 6 to 2 to 2. I could actually divide everything by 2 and get a 3 to 1 to 1 ratio. But for this particular equation, I just basically scaled everything up. We'll see it doesn't actually make any difference in the long term. But when you write chemical equations, you should have them in the lowest common denominator, which I did not, but that's okay. We have 3,873.4 grams of magnesium. We have an excess of nitrogen, so nitrogen is in abundance. And we want to know how many kilograms of magnesium nitride can we synthesize under these conditions. We're told that the reaction is 100% yield. Okay, so again, this is a factor label, a dimensional analysis type problem. So 3,873.4 grams of magnesium is going to equal some value in kilograms of magnesium nitride. We have grams of magnesium, we want kilograms of magnesium nitride. The relationship, we have 6 moles to 2 moles. However, those are moles. This is grams. So now this is where we begin our unit conversions. So the most logical thing to do is convert from grams of magnesium to moles of magnesium. Again, why I say that's logical is the only way to use the chemical equation, the balanced chemical equation, is if you are in the unit of mole. Gram, kilogram, pound, ounce, liter, none of those will actually be useful when we're talking about a balanced chemical equation. So we would have to convert it into moles. And the way to do that is with the molar mass. So 24.31 grams of magnesium is equivalent to 1 mole of magnesium. Grams cancel, grams of magnesium cancel. Now we have moles. We want magnesium nitride, right, in kilograms, but first we have to get to it in moles. 6 to 2. So 6 moles of magnesium is equivalent to 2 moles of magnesium nitride. Now, when I wrote this equation, I basically scaled this up by a factor of 2, 6 to 2 to 2. It should be 3 to 1 to 1, but mathematically, it's not going to make any difference. 6 divided by 2 is 1/3, right? In other words, so I could have scaled this up to 60 to 20, and it would have no effect because this would stay the same from a mathematical point of view. In other words, if I divide through, it's the same ratio. So moles cancel. So now in moles of magnesium nitride. We need kilograms, so we're going to go now from moles to grams. And off to the side somewhere, you should have calculated what this molar mass was. Sometimes I'll provide you the molar mass, other times I make you do it yourself. Moles cancel, now we're in grams. Normally we would be done, but I've asked for the unit of kilogram. 1 kilogram kg, is 1,000 grams. significant number of you got this reversed. You actually said 1 gram is 1,000 kilograms. So you need to be thinking about, again, kilo, 1,000. A kilogram is heavy. A gram is very, very light. So that's something that, it's very easy to invert this. So a lot of you basically got the answer wrong by a factor of 1,000. In other words, you multiplied by 1,000. So to place that in our dimensional analysis, 1,000 grams of magnesium nitride is equivalent to 1 kilogram of magnesium nitride. So we're dividing by 1,000. Grams cancel, and when all is said and done, you get 5.361 kilograms, of magnesium nitride. So 5.361 kilograms of magnesium nitride. Significant figures. We start with 5 significant figures. The periodic table that I gave you only has magnesium to 4, so that limits us. Everything else, this has more than 4, it has 5 significant figures. This is actually an infinite number of significant figures because it's a definition. Now, again, in this case, if you didn't get the significant figures correct, it wasn't a big deal because it's about the process of solving. 1, 2, 3, 4 steps. Again, dimensional analysis will bring us home for these type of problems. If you try and attack it any other way, you basically run into all kinds of problems and you don't even know it. Because again, with dimensional analysis, if I invert something, very quickly I'll realize it's wrong because it won't cancel.